Hey, so I finally got around to showing you how to teach elimination versus substitution. So we have substitution versus elimination. So let's just take a problem. Let's make up one. Here's how I make up these kind of problems. I start with the answer. Let's say the answer is x is 2 and y is 3. So, of course, you wouldn't give kids that at the beginning, but this is how teachers make up problems. So you just have to make it true. Something like y equals x plus 1. So see if you put a 2 there and a 3 there. That's true. So there could be 1. And let's say the other one is 2x plus 3y equals, so that would be 2 times 2 is 4, plus 3 times 3, which is 9. So 4 plus 9 is 13. So let's say those are the two equations. So yeah, substitution. If it's solved for y, you can just take that and stick it in for y. So you have 2x plus 3 times x plus 1. See, now you only have one variable, so okay, 3 times x is 3x. 3 times 1 is 3. Put these two together, so we have 5x. Okay, I'm going to pick up this positive 3 and put it over there as negative 3. So I have, that's how I teach that. I don't put minus 3, minus 3. I teach if it's on one side, it's its inverse on the other side. So there's 10, divide by 5, and x is 2. Check. And then you got to substitute it again, so I'll substitute it back up in there. So now that one is y equals, we know x is 2, and there we have y is 3. Check, so that worked. So that's the substitution method. The problem with substitution is if it's fractions. See, nobody ever gave you a fraction probably when you're doing it. So substitution, you were fine with substitution. Let me just make up another one. I'm just going to make this up now. Let's say we have y equals 2x minus 5 and 2x minus 7y equals 10. My guess is that doesn't work out very well. So here I'm going to take the 2x and stick it in again. So now I have 2x minus 7 times 2x minus 5. Now this is a negative 7. Kids miss that all the time. So negative 7 times 2x is negative 14. And negative 7 times negative 5 is positive 35. You have to emphasize that. You'll be emphasizing that your entire career, that negative 7 and negative 5 is positive 13. Now that's negative 12. I'm going to move the 35 to the other side. So now I have negative 12x and negative 15. So dividing off the negative 12. Now x equals 15 twelfths, which reduces by, what, 3? So 15 divided by 3 is 5 fourths, so it's 5 fourths. See, now you don't have something quite as nice. Now you got to take this 5 fourths and go stick it back up there, and it becomes a fraction problem. So 2, of course you can do it. It's 5 fourths minus 5, so I actually got a pretty clean one. 2 over 1, so that 2 can cancel that 4 down to a 2, so it's 5 halves minus 5 ones, so that's 5 halves minus, multiply that by 2, is 10 halves. So 5 halves minus 10 halves is negative 5 halves. So it's a hassle doing that. Okay, here's what elimination does. Elimination would have worked much better for that one. So when we're doing substitution, see, it's still, the very first step still gets rid of one of the letters. So see, you're trying to get rid of one of the x's or the y's. Elimination does it like this. If you have 2x plus 3y equals 9 and 2x minus 3y equals 4, if you now take this whole group and add up the x's, if I take those and add them together, we get 4x. If we take those and add them together, we get 0. And if we take those and add them together, we get 13. And now we can divide by 4, and x is 13 fourths. Now you do have to go sub it back up in there, but I'm going to show you a different way. But I just wanted to make sure we knew what elimination is doing. Elimination means one of the letters are getting eliminated. So if you don't have that, let's say it's 2x plus 5y equals 10, and maybe 3x minus 4y equals 7, something like that. Okay, you have to force elimination. Now, it doesn't matter which one we force, you just have to force one. So I like to work these sideways. I'm going to get just a little bit more paper. Let's say I try to make these the same, since one's positive and one's negative. If I multiply this whole thing times 4, see, that's going to make 20. And if I multiply this whole thing times 5, it's going to make that one 20. They'll both be 20. So if I take all of this times 4, so 2x times 4 is 8x. 2x times 5 is positive 10y, and 4 times 10 is 40. See, that's the same equation. It's just been cranked up times 4. I'm going to crank this one up times 5. So that's 15x. 5 times 4 is negative. Oops. 4 times 5 right there should have been 20y. Sorry. And now 5 times 4 here is negative 20y. See, the goal was to get those 20s the same. And now 5 times 7 is 35. Now when we add them up, see, when I added up that 0, it was eliminated. So 8 plus 15 is 23. That's gone. And over here, 40 plus 35 is 75, and we can divide by 23. So the x is 75/23. So that also is not a very nice one. We would have to take that. Sorry. We would have to take that and go sub it back in one of the originals and see what it is. Okay, here's why elimination is really useful. Let's just say we have something like, here's elimination again. Well, let's go do it back on that problem that I had. This one over here, where it ended up with fractions. So we have y equals 2x minus 5, and the other one was 2x minus 7y equals 10. I like elimination a lot, so we'll have to organize it a little bit. This one is good. I'm going to move this one around so that the x and y are on the same side. So I'm going to pick this 2x up and put it over here. So that would make it a minus 2x, and then there would be this y. And then this side would have the negative 5. So I just rewrote it so the negative 2x was over here. I took it from there and put it over here, and now stacked it up. Just so happens the x's are already gone. So when I add those up, those add up to 0. Adding these up, it adds up to negative 6y. And adding these up adds up to 5. Divide off the negative 6, divide off the negative 6, and y equals negative 5, 6. That should have been the same answers over here. So I made a mistake on one of them. Let's see. I either made a mistake over here, which is probable, or I made it over here. I could go back and find it. You probably have already seen it. What did I do here? 2x minus 5, that makes negative 14, positive 35, negative 12. Okay, it was right here. Okay, so the 10 minus 35 was 25. I thought I probably missed it over here. So this is 25, 12, and blah, blah, blah. So this one was actually wrong. It's easier to get it right over here. So the y is actually negative 5, 6, not this one. Okay, but the reason that I think elimination is easier is you don't have to go sub this in and get it. You can just start over. It was negative 2x plus y equals negative 5. That was this one. And the other one was 2x minus 7y equals 10. You can just do elimination again for the other one. So we found, so this one we made the x disappear. Let's just crank it up so the y disappears. I'm going to multiply all this times negative 7. So negative 7 times 2 is now 14x. Negative 7 times y, oh, I need it positive 7. So positive 7 times negative 2 is negative 14. 7 times y is positive 7y. And 7 times negative 5 is negative 35. And see, now that eliminates the y, and it'll just give us the x answer. See, here's negative 12x. Here's negative 25. Divide off the negative 12. So there it is. X is negative positive 25/12, just like it was over there, what it was supposed to be over there. So see, we never had to substitute in any negatives. We never actually had to work with negatives, I mean fractions. We did actually never had to work with fractions even when the answers were fractions. Let me show you just one more. So let's say we have something like 3x plus 2y equals 10, and maybe 4x plus 3y equals negative 5. Okay, going this way, I'm going to try to crank the x's up. So see, this way I'm going to make the x's to become 12. So I'm going to multiply everything here times 4. Okay, so 3 times 4 is 12x, 2 times 4 is 8y, and 4 times 10 is 40. And then this one I'm going to multiply by 3 so that I get the 12s in common. So 4 times 3 is 12x, 3 times 3 is 9y, and negative 5 times 3 is negative 15. Now, I need one of them to be a negative. I need one of these to be a negative because when I add them up, I want it to add up to 0. So I'll just make the top one. I'll multiply by negative 1. So I could have multiplied everything by negative 4. But I'd save the negatives for last. Okay, those are now 0. These add up to y. These add up to negative 55. Okay, probably it would be easier just to sub in, but let's pretend that was a fraction. See, now we can go this way, and I'm going to get rid of the y's. So I'm going to multiply this one times 3, so that's going to be 9x. 3 times 2 is 6y, and 3 times 10 is 30. I'm going to multiply these by 2. 2 times 4 is 8x. 2 times 3 is 6y, and 2 times negative 5 is negative 10. This time I'm going to change all these signs, so negative, negative, positive. Now the y's are gone. 9x minus 8x is x, and 30 plus 10 is 40. So had this one been a fraction, I wouldn't. The advantage is I made up a problem that accidentally worked out cleanly. I was hoping it would work out not so cleanly. Had this been a fraction, you'd have to go sub it in and deal with fractions. But if you just go the other way, you'll get the other one over here without ever having to sub in a fraction. That's the advantage of elimination.